Okay, hello everybody. I am sitting here with the grade 6 or 7A class. Everyone say hello. There we go. As you can tell, we are live once again, so I have no idea what's about to happen. So just stay with me. Okay, so we are introducing a new concept. That concept is called Pythagorean. What does that spell? Pythagorean theory. Okay. That's a P. That's a Y right there. See, they're making fun of me already. Can you believe that? Theory. It's called Pythagorean theory. If you're taking notes, write it down. You want to write it down quick because I'm not going slow right now. If you're just watching, you can watch this later. Okay? That's a crazy little gremlin laugh over there. So Pythagorean theory is this beautiful, beautiful formula that was invented by a man whose last name was Pythagoras. Pythagoras is a really weird dude. Okay, Pythagoras never wore shoes. Okay, Pythagoras was actually executed because of his ideas. Pythagoras also believed that when he brought groups of academics together, that no one was allowed to talk academically until everyone had had 3 glasses of wine. Okay, so sometimes the individuals who have created these formulas and theories, not all of their theories were good. Okay, so Pythagorean theory is this beautiful theory that deals with a specific kind of triangle. Who can tell me the 6, remember sign language 6, types of triangles? Who can tell me one? Yeah?
Right triangle.
Right triangle, that's the most important one, right? Okay, what's another one?
Obtuse.
Obtuse, what's an obtuse triangle?
It's one that's larger than 90.
That's right, angle larger than 90. Great, who can tell me another one? Yep, right there, sorry.
Acute.
Acute, what's an acute triangle?
It's like a little triangle. And
The little triangle.
The angle between the corners are less than 90 degrees.
Yep, awesome. What's another one?
Equilateral.
Equilateral, what's that mean?
I think it's like equilateral.
Yeah, equal on all sides. Okay, we got a couple more, yeah?
Scalene.
Scalene, which is?
Equal on 2 sides.
Different on the bottom. Yep, last one.
Isosceles.
Isosceles, what's that?
2 of the sides are the same and 1 is.
2 of the sides the same, 1 is not. Perfect. Okay, what is the most important line of all triangles when we're dealing with Pythagorean theory? Remember? Yep.
Hypotenuse.
It's called the hypotenuse, okay? The hypotenuse, not the hypotenuse, not the hippopotamus, not the hippopotamus. It's called the hypotenuse. All right? Now, and not the hippopotamus. Okay, now we've been working with square and square root, yes? Okay, so what I'm going to do is I'm going to draw a line. Okay? That line is 5 centimeters long. How long is it?
5 centimeters.
Who can tell me what the square of that line is? Right over there, Ansel.
25.
It's 25. So if I draw a square off of that line, and I take the square of it, the square would be 5 times 5. That's going to be 25 units squared. Is everyone in agreement with that? Yeah. Anything that I've asked you to do that you haven't done yet? No, this is all the same. So, next thing. If I draw a triangle off of that, that is a right triangle. It kind of looks like an upside down house right now. Okay? And what I'm going to do is I'm going to put the number 3 down below and the number 4 on this other side. Now, we've talked about the black line. The black line. What's the black line called?
The black line.
This is called the hypotenuse. Hypotenuse. The hypotenuse, in my last class, someone described it in the most beautiful way. It's the line that would cut the rectangle in half. What does that mean? If I have a rectangle, do you see how that right there is my hypotenuse? What is it opposite? The right angle. Okay, so there's a really easy way to figure out where the hypotenuse is. What you do is, I used to do this even in university. I liked my different colored pens. I had a 4-colored pen. And you go, beep, 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 beep. The hypotenuse is like a little bow and arrow that shoots at the hypotenuse. Okay? Hypotenuse is always the longest side. Yes?
So is the hypotenuse the 5 centimeter line?
It's the 5. Yeah. So the 5 centimeter line is the hypotenuse. Okay, so what is the square of the hypotenuse?
25.
25. Why is it 25 and not 5?
Times it by 5.
Because I have to square it, which is 5 times 5. So the square of the hypotenuse is 25. Fantastic. Okay, what happens if I square one of my legs? So if that is 3 centimeters here, and I square it, what is the square? That doesn't look like a square, does it? Is that better?
Yeah.
A little bit. What is the square of the leg of 3 centimeters? Yes, it's 9 units squared. Okay, what do you think the next question I'm going to ask is? Yep.
What the triangle is.
Oh, no, not quite. What is the square of the leg that's 4 centimeters? This is 16 units squared. Okay. Is there anything I've done there that you're like, how did he get that number?
Right now, I'm honestly just trying to write everything down.
That's right. Don't worry about it. I've got this recorded, right? So sometimes it's better just to sit and watch. Okay? Yeah, so just watch it. You got 2 weeks to take notes coming up here, Izzy. Yes, Bastion.
The triangle is 6 units squared.
Oh, cool. I don't actually care about it right now. Okay? So the whole point of Pythagorean theorem is to allow us to figure out the side lengths of a triangle. It's a ratio. Okay? If I have a triangle that's really short like this, or if I have a triangle that's almost perfectly straight like that, or if I have one that looks like this, we can use Pythagorean theorem to find the length of the hypotenuse if we know the legs. Now, it's a weird thing. We call them legs. The only way I can ever visualize this is that that's my 90-degree angle, and this is a guide. Okay? What the ground is going to be, I know that looks ridiculous. The ground is going to be the hypotenuse. Okay? I know I won't leave it up there very long. So the legs are going to be anything that is not the hypotenuse. Yeah, giggle now. Right, now, what I'm going to have you do next is you can't quite see that. I'll put this in black. What I'd like you to do is I want everyone just to close your eyes for a second, and I want you to get really calm. No, don't snort. Remember, when I ask you to close your eyes, I need you to actually pay attention. So close your eyes. Notice, I need you not to make any noises right now, okay? I need your word here. Close your eyes. Listen to what I'm about to say. It's going to sound really complicated the first couple of times. Okay? The square of the hypotenuse is equal to the sum of the square of the other two sides. Close your eyes. I'm going to say it again. The square of the hypotenuse is equal to the sum of the square of the other two sides.
Phone starts ringing.
Okay, one more time. The square of the hypotenuse is equal to the sum of the square of the other two sides. I want you to repeat that to yourself twice. Okay, in your head. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay, now open your eyes. What is the square of my hypotenuse? The square of my hypotenuse. It's 25, right? So if I have 25, that is going to be equal to what? The square of the other two sides. So that's going to be 16 plus 9. Well, what is 16 plus 9? What is it? 25. So 25 is equal to 25. What's up, man?
Do you know where the laptop cart is?
No idea. Okay? So this big area has to be equal to the square of the other two sides. Okay? When we write it in true notation, it looks like this. A squared plus B squared. I'm going to write it the other way. C squared equals A squared plus B squared. What do you think C is a representation of? What is the longest side? It's a hypotenuse. The hypotenuse is always going to be C. My legs are going to be A and B. Ideally, they go in order. So the smallest one is A, but it doesn't matter. The legs doesn't matter which. Okay? So This looks like this. If I have C, what is C? C is my original number. So this is 5 squared equals 3 squared plus 4 squared. That's what your notation is going to look like. What is 5 squared?
25.
25 equals 9 plus 16. 25 equals 25. All this tells us is that this is a 90-degree triangle. Okay? What is the side length of this square? 4. How would you get there if I told you the side length or the volume is 16? What is the side length? What operation would I use? Square root. So if I want to know what the side length is, I have to take the square root. Whew, that's a lot of information, isn't it?
Yes.
Yes, question. Go ahead, you don't have to ask. Go ahead. Just go over this way so you're not on camera. Thanks.
A big window.
All right. Here's a triangle. This is going to be, what's some numbers we have here? We could do 6, 8, and I don't know. So here we've got a triangle. I don't know the hypotenuse. What do we know about it?
That's a triangle.
It's a triangle. What kind of a triangle?
A triangle.
It's a right triangle. As soon as I have a right triangle, I can now use I can use Pythagorean theorem. Okay? So what is our theory? Does anyone remember it? C squared A squared plus B squared. That's the theory. That's the theory. Now, next week, 2 weeks, I'm going to teach you how to use the formula. I like it better. I want you using this to start with. Now, what do we do? Like in a word problem, we go A, B, and C.
A, B, C, D, E, F, G.
Very good. Okay? What is my longest side? It's always going to be
A, B,
C.
D, E.
So C is my unknown. I don't know what my C is. I don't know.
There's actually a higher one than C.
Not in this, there's not, because I only have 3 sides.
Oh, well,
Okay? What should we make 8? 6 or 8? Does it matter?
No.
Doesn't really matter. Let's make it 6. We'll make this 8. Are you with me?
No.
Not really? These are the legs. The legs of the triangle are A and B. So this is A. This equals B. So I've labeled my triangle A, B, C. What is C? C is always my hypotenuse. It's always the longest side. It has to be. Okay? Just like this. If I have a triangle like this and I go 1, 2, 3, technically I would label that A, B, C is always the longest side. I used to teach this with an H, but in high school, they are going to use C, not H. So you got to learn that C is always your hypotenuse. What is C?
Hypotenuse.
Always your hypotenuse. That's too close. All right. So now what we do is we're going to take our number, 6. Where does 6 go? Goes in for what?
A.
A. What does it go in for?
A.
A. Are you Canadian?
No.
A.
Yes, we're Canadian.
C squared equals, this is going to be 6 squared plus, what's my B? 8 squared. Now, here we go. C squared equals, what is 6 squared?
36.
36. Someone did his homework. What's 8 squared?
64.
64. You don't have to know those off by heart, but it's pretty handy. Okay? So now, I get C squared equals 100. Now, I've just told you that the square of C is 100. Does that give me the area or the side length? If it's the square.
That would be 10 area.
Yeah, so this tells me the area. So how did you get to 10?
Because it's squared. It would be,
So we need to take
it
the...
would be multiplying it by itself.
That's right. So we have to take the square root of both sides. Okay? This is the step that most of you are going to mess up on. So once you get down to that last number, we're going to go C equals 10. Bing, 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 bing. C equals 10. That's it. You have to identify what the longest side is. Black line. Long line. That's the hypotenuse. Once you have that, we go through and we square it. Okay? Any questions on that? Thank you. I'm going to do one really neat, and then I'm going to shut this off. Okay? We're going to do a hard one. Who's got a calculator?
You're gonna shut off the numbers?
Who's got a calculator? No, I'm not going to. Someone got a calculator?
Yeah. I have one.
All right, get your calculator up.
It's right here.
Good. All right. So, your homework is not going to be nice, small little numbers. Why? Because that's boring. So let's make a triangle. I'll do this one super, super neat. Okay, I'll show you how nice I can write. 3.4. Actually, no, let's just make it 34. 34 and 21. What's the very first thing I'm going to do? Think about word problems. A, B, C. Just write it down. A, B, C. A. Which one is going to be C first off?
The long one.
My unknown. I don't know it. What's A? Let's call it 21. What's B? 34. Great. So we're looking for C. We're looking for the hypotenuse. That's really important. I would even go A and B. Label them on your diagram. Okay? Next thing. What's my formula? C squared. A squared plus B squared.
C equals A plus B.
Yeah, C squared equals A squared plus B squared. So because remember, the theory is all about the area. That's right. That's exactly it. So C squared is what we don't know. So A squared is going to be 21 squared.
Wait, couldn't C be,
I know C is the only one that has to be itself. Because it's across, it's the hypotenuse, so it's across from this 90-degree angle. So C always has to be the longest side. Be really important in 2 weeks. Okay, because we're going to start to solve for the legs, not the hypotenuse. Okay, so calculators, what is 21 squared?
It's 34 times.
No, what's 21 squared? Calculators, let's go.
He's a calculator.
1.414.
21 squared? Can't be a point.
421.
441? Okay, what is 34 squared? Calculator time.
34.
Okay, what's 34 squared now?
34.
What was
Calculators, let's go.
34 squared?
Yeah, 34 times 34. 1,165? 56. Okay, can someone add those two numbers together for me now?
Yeah, I can.
441 plus 1,156. 96? 97. Like that?
Yeah.
Okay, now look. Do you guys notice that I've put my C squared on every single line? This tells me that the square of C is equal to this. How do I find the side length? I have to take the square root, like so. Someone with a calculator, can you please take the square root of 1,597? 39.9. Good enough.
39. Could you just say 21 and 34?
No, you cannot. Order of ops. Order of ops. You have to do the exponents first. Okay, if you do 21 plus 34, that number is going to be way different. Okay, so guys, in here, this is the summary unit of your last 4 units. Order of ops, integers, and exponents. All of the rules still apply. All right? Thank you, everybody. I hope that helps. That's the new notation I want you to use. Okay, pause.